Okay, so we're on day 2 of 9.5. We'll be using the discriminant of the quadratic formula. So the entire quadratic formula looks like this. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But there's a part of the quadratic formula that's so important that it has its own name. And that part is the b squared minus 4ac. That part of the quadratic formula is called the discriminant. So the discriminant looks like this. Just the b squared minus 4ac. And depending on the value of the discriminant, that will tell you exactly how many solutions of the quadratic formula you would have. And you would either have 2 solutions if the discriminant's positive. If the discriminant is negative, you'd be taking the square root of a negative number. And as you saw, that's not possible. So you would have no solutions. And then the discriminant could be 0. If you're taking the square root of 0, you would be adding 0 and subtracting 0, which is the same thing. There would just be one solution. So here's what we determined. If the discriminant is greater than 0, that means it's positive, then there's 2 solutions to your quadratic equation. If the discriminant is negative or less than 0, then there's no solutions to your quadratic equation. Or if the discriminant is equal to 0, there would be one solution to your quadratic equation. And those are the 3 possibilities for any quadratic equation. Now, just trying to apply that on exercises or problems 8 through 10, it says determine the number of real solutions of the equation. So what that's really asking you to do is, 1, evaluate the discriminant, and then 2, use that to try to determine the number of solutions. Okay, so we still want to figure out A, B, and C. A is -1, B is 6, and then C is 3. But I'm not using the entire quadratic formula. I'm just trying to evaluate the b squared minus 4ac part. So b squared minus 4 times a times c would be 6 squared minus 4 times -1 times 3. And then you just do the math. 6 squared is 36. -4 times -1 is +4 times 3 would be 12. So 36 plus 12 is 48. This is positive. It's more than 0. So since b squared minus 4ac is positive, there would be 2 solutions. It's not asking you to find the solutions. It's just asking you how many. Okay, then I'm going to move to number 10. A is 1, B is 3, and then C is 8. So we just evaluate the discriminant. Again, just the b squared minus 4ac part. So that'd be 3 squared. That's b squared minus 4 times a times c. So 3 squared is 9 minus 4 times 1 is 4 times 8 is 32. So 9 minus 32, that's -23. Since it's negative, then there would be no solutions to the quadratic equation. Now for exercises or problems 11 through 13, the directions are different, but really it's the same thing. It says determine the number of x-intercepts of the graph of the function. It doesn't say to graph the function. We're just trying to figure out the number of x-intercepts, which is also the same as the number of solutions, which is actually also the same as the number of roots, or it's the same as the number of zeros. There's just a bunch of different names for the solutions. Roots, zeros, solutions, or x-intercepts. So we still want to figure out A, B, and C. A is -1, B is 4, and then C is 3. And we could just evaluate the discriminant, b squared minus 4ac. So it's 4 squared minus 4 times -1 times 3. 4 squared is 16. -4 times -1 is +4. And then times 3 is +12. 16 plus 12 is +28. Since this is positive, then there would be 2 solutions, which also means 2 x-intercepts. I should actually write. Since there's 2 solutions, there would be 2 x-intercepts. For number 12, A is 1, B is 14, and then C is 49. I'm going to cross this out so you don't confuse my work for number 12 with number 13. But then we could evaluate the discriminant. So b squared, 14 squared minus 4 times 1 times 49. Okay. So 14 squared, that's 196 minus 4 times 1 is 4. And then 4 times 49 is 196. So 196 minus 196, 0. Since the discriminant is 0, there's only one solution, which also means there's one x-intercept. So if you're asked to find the number of solutions, the number of x-intercepts, it could also ask you to find the number of zeros. It could also ask you to find the number of roots. Then really you're just evaluating the discriminant of the quadratic formula. If the discriminant's positive, there would be 2 solutions. Negative, no solutions. 0, 1 solution. Thank you. Have a good day.